Hey everybody. This talk is going to be called Building Cross-Platform Design Systems. I'm Guillermo de Fermin, a little bit about me. I work at Taxfix as a staff software engineer. You might have heard of us, and I am the tech lead of the design system project, or I was for the duration of the project. Hit me up on socials, and we can also chat after the talk if you want. And let's get right into it. So I think that the first thing to kind of that I want to lay out is what is actually a design system. I think there's two parts. I kind of put them here a little bit to scale, sort of like what's the most important part, and it's this like rules and guides that you have for designers. So it's something built by designers for designers, and it's so that they just speak a common language and they design using the same rules. And then there's a very handy part that comes with it that is sort of like the code. So components that you can use so that developers that are going to be implementing stuff that those designers are designing, they can do it like super easily, super quickly, and they don't have to like reinvent the wheel for things that are just common. So I'm going to be talking about the second part in this talk. So mainly how we build, the tech side of the design system. But like just keep in mind that this other part is also really, really important. Also, even if you don't have a designer in your team, or even if you're not that big of a team and you think, well, maybe we don't need these rules and principles for designers, that's also fine. I think you can just create a component library and you can get a lot of these same benefits. I probably wouldn't call it a design system, but I think a lot of the same concepts apply. So probably everything I'm going to talk about in this talk is going to be useful, hopefully. We wanted to build one at Taxfix that was cross-platform. So for us, basically that just means Android, iOS, and web, which is the three platforms that we want to support. We use React Native already for our app. So for Android and iOS, this was like a no-brainer. Let's just use React Native also for our component library for the design system. For web, you kind of have a few options. A lot of people in the industry just create like a separate library for web, and depending on your situation, that can work very well. For us, we wanted to make sure that it was that we followed the same API across Android, iOS, and web, and we wanted to enable our teams to be able to also just write code once and ship it to all three platforms. So in order to do that, we went for React Native Web, which basically gives us, if you just want to go for one of these platforms, you can still use our library, but if you want to write code once and deploy it everywhere, it still works. When we started thinking of building this, we thought, okay, so we have a few options. We could just start from scratch, and I think that could work, or we could use a library. At the time, there weren't very many libraries to sort of help you out that work for like React Native and web. So we ended up going for native base, which was the only one that was kind of mature enough to sort of fill that void. But now there's other libraries like GlueStack and Tamagui that also are other options that are very nice. Native base has been deprecated, so you probably shouldn't be using that if you're starting a design system now. But the creators of native base are the ones that created GlueStack. But I would actually personally go for Tamagui. I think it's a really, really interesting library. I've played around with it a couple of times, and it looks very, very promising. But yeah, the main question here, should I use a library? My opinion is that like getting a library to sort of help you kickstart the process of building a design system is really nice, because like whenever you build a design system, the initial start of it is gonna like take a long time, And people are not going to start using your design system until you actually have like a bunch of components, right? When you only have 3 components, nobody's going to like create a screen, but yeah, only the buttons are coming from the design system. So there's going to be like a period of time where you're just like working on your own, and nobody's actually going to be using your components. And that's very dangerous, because if nobody uses you, then you don't know if you have bugs, you don't know if it actually works. So if you can minimize that time, if you can take any shortcuts, like using a library, I would highly recommend it. And so more tools that we used for our design system. So we needed to find something to host docs for our components, and also a developer playground so that we could, just write our components without having to like import them in some other app and so on. A really nice tool that we found to do both of these things was Storybook. Basically, the main appeal here of Storybook is that it does these 2 things. So you don't have to configure 2 separate tools. If you do, feel like configuring 2 separate tools, you can probably find sort of more specialized tooling to do these 2 things separately. So I'm sure, for example, for docs, stuff like Doctosaurus is gonna give you like a lot more features, a lot more options. But just having only one tool to configure is also just a really nice shortcut that you can take at the beginning, and it just makes your life easier. So yeah, that's what we went for. I can show you actually what that looks like. So this is the documentation page that we built. Yeah, you can see this is basically just markdown stuff rendered here with some documentation. You can check like we have some pages for each component, and you have like really nice live examples here, which are super nice. You can show the code, and like you can guarantee that if you copy paste this code, it's going to render this example exactly. So this is super nice. You can even go to like the bottom and check like the API documentation, and you have just like this table of like every single prop that the button accepts, which is really cool. This is auto-generated from like the TS doc, and then you even have like these little toggles here where you can just kind of play around with the props and see what they actually do. So yeah, that's basically our Storybook. We found it super useful, both as docs, but also just as a developer playground, because it's super easy to just create a story, add an example, and just test whatever you want to test. And speaking of testing, this is super important. So at the beginning, we only had unit tests with Jest, and we had a few, and they caught a few bugs. But we started adding visual regression tests with Playwright. So what this is basically is we just use Playwright to take a screenshot of like every single story that we have here in Storybook. So you can see actually like you can go to these like separate stories. And so we can just use Playwright to just go through all of these and take a picture and just commit them to Git. And then on every PR that you do, it's going to take the screenshots again and compare them with the baseline. And if something changes, it's going to fail your CI. So the sort of normal workflow would be, okay, well, let's say you have a PR here to update like the slider color. So you can see like this is like a change that you actually want to happen, right? You have so the previous color was a little bit darker than the new one. So like your CI is going to fail because it's going to say, hey, the screenshots don't match. But that's okay. You can just say, okay, I accept these changes. And then as you can see, like you're just going to add these like new screenshots to your PR. Anybody reviewing your PR is going to be able to look at the screenshots and say if those changes actually make sense or not. In this case, they do. So then the PR is merged, and that just becomes the new baseline. So super easy to work with. And the cool thing is this is like actually super useful at catching bugs. I want to give like a quick example of how we actually caught like a visual regression that I think probably without this we wouldn't have caught. This like PR, it was basically about changing how animated background for the button works. So if you know a little bit about transitions in React Native, basically there are some animations that you can do using the native thread and some that you can't. And changing from one color to another is one of those animations that you just can't do on the native thread. But what you can do is have like 2 layers of different color that have different opacities, and then just like fade them in and out. And that actually works because the opacity is something that you can do on the native thread. So you can get a nice little performance boost by doing this. And so I created this PR, I tested it, I tested the button component, made sure everything was working. Everything seemed okay, but then I saw that my CI was failing. So I go to the report and I see the split button is failing. So that was kind of weird to me because like in my mind, the button and the split button were 2 separate components. And you can see this is like how the split button should look. But if you can see the actual screenshot it took was that. So yeah, that's not good. It turns out, well, the split button is using like the button underneath, under the hood, and it's just like overriding some padding that it has to make it like look square instead of the normal way that it would look. But because now we have 2 layers, we have to make sure to like pass those props correctly to like both layers so that everything works. And I wasn't doing that. So thankfully, we caught the error and we fixed it. But yeah, without this, it would have been like super, super hard. Sometimes, you're changing a component and you don't know what side effects it's going to have, what other components are going to depend on it. Having this safety net that is going to check all your components on every PR is super, super important. So yeah. And then sort of the last thing I want to talk about a little bit is how we try to balance extending and adding restrictions. I think all of us as developers like value extensibility a lot, and for good reason. I think anything that you can extend and hack and modify is generally very good. But you run into situations where that can be kind of a double-edged sword. So this screenshot here was from like a previous attempt that we had at Taxfix of creating a design system. And you can see here that we had teams saying, yeah, we're using the design system. But then they're grabbing like a design system component and completely like overriding a bunch of styles, a bunch of like internal things. They're adding like a hard-coded color in here. So you can imagine that whenever we make an update to the design system or whenever we decide to introduce a new theme or anything like that, none of this is going to work, right? It's just going to break. So it's kind of as if we didn't have a design system. So it is interesting to kind of find this sweet spot between not restricting too much and not extending or giving developers so many possibilities that they can just override absolutely everything. Probably a better situation for whoever had to do all these overrides would be to reach out to us and say, hey, like your design system component is not doing what I think it should be doing. Why is that? And maybe it's a bug in the component, but like a lot of the times it's just that maybe you're not using the right component, or maybe the designer made a mistake and was using like an older version. But most of the times you can just avoid all of this overriding and just use the design system component as is. So yeah, you got to be a little bit careful with that. A nice little pattern that we started adopting in order to kind of try to hit this sweet spot was to have some sort of like smart context-aware default props. So if you just render the avatar component just like that without any props, by default it's gonna create like a round avatar. But if you do the same thing, you render like an avatar component without any props, inside a list item, it's gonna create a square one. Because we have some rules that say that generally if you're rendering an avatar in the design system inside a list, that it should be a square one. So if for some reason you need to change this, you can always manually pass, variant equals round or variant equals square, and it's gonna respect it wherever you do it. But if you don't, like the default or the easiest path is gonna be to just follow the rules of the design system. So yeah, super simple how we did this. Since we're in React Native, we don't have like CSS inheritance, which would be another nice way to do this. But we can just do it with a context. Basically here in the avatar, we're listening to like an overrides context, and then we're merging that with whatever props the user passes. And then in the list item, we're just wrapping the children that you render with a context, providing like the override for the default value that we want. So yeah. And yeah, so takeaways. Super important, I think, to minimize the initial effort as much as you can. I think it's where, you know, like if you can get like a super short initial effort and then start having people use your design system as quickly as possible, you're gonna be able to work much more quickly. Just because you're going to have like a lot of bugs and a lot of things that are only gonna show up once people actually start using what you're building. Yeah, right balance of restrictions and extensiveness. It's tough to find the sweet spot. It's pretty tough, but I think if you're in doubt, you should restrict. Because if you restrict too much, people are going to get angry at you, but you'll know about it because they'll reach out to you and they'll tell you, hey, your component doesn't work. If you extend, like if you let them extend too much, you're not going to know about it because they're just going to override your components, and you'll know when it's too late. So yeah, if you're unsure, restrict. And yeah, add screenshot test. I think they've like really helped us catch a lot of bugs, and yeah, they just speed up our development process. And yeah, so next steps that we want to focus on for our design system, we're already looking into improving the performance of components. So all of these things we kind of, you know, did sort of a best effort thing. We tried to make them performant, but you know, without actually profiling and testing them, you're never really sure what that means. So now we started profiling components and like really testing them and making sure that the performance is at a right level. We want to do the same thing with the accessibility. Again, we did sort of like a best effort thing, which is going to be, yeah, maybe some components work with screen readers, maybe some components work with like the keyboard, but maybe some don't, and that's going to suck. So we need to, you know, put some tests and make sure that every component works and that everything works as expected. And then also the same like visual regression tests that we had. So these tests on Playwright, they're just using the stories from Storybook. So this is only for like web. We'd like to do the same thing for native because like apart from having like we do have a bunch of platform specific code. So you know, if you have some code that's only for iOS, you're basically not testing it with these web specific tests. But also, you know, maybe you depend on some libraries that have some weird behavior on certain platforms. It's nice to test all the platforms that you're supporting, and right now we're only testing web. So yeah, that's also like a really high priority. And yeah, that's it. Thank you for listening, everybody. I think maybe we have some time for Q&A, and then if not, I'm going to be around later so we can chat one-on-one.